To continue our Western blotting protocol, all we're going to do is incubate it with a series of different solutions. One of the things we have to realize is that since the membrane is able to bind proteins, and since antibodies are proteins, we don't want our antibodies to stick to areas where they shouldn't. So we do what's called a block. We just add a high protein solution. In this case, we're using skim milk powder in TBST, and then just incubate it. And if you're going to do 2 blots, make sure that they're back to back so the proteins can be exposed. Gentle shaking, and let this sit for an hour. Or if you'd like, you can do this overnight, either in cold room or on ice. All right, so our blocking is done. Now we want to remove or wash away any of the solution, our blocking solution. So just simply dump in the sink, add TBST, and we're going to do 3 washes at 10 minutes. So gentle shaking, a little bit too fast, so making kind of a mess, right? But that's for me to clean up afterwards. But 3 times, 10 minutes each. And while we're washing, here's one of our wash steps. I'm going to prepare the next step, incubation with the antibody. Now, there are a number of ways to do it. Ideally, you'd like a container that's like the perfect size of your membranes. But since we don't have, we're going to use plastic baggies and this heat sealer. A little bit of an issue in the leak sometimes. So you just got to be careful and that there are no leaks. So I think what I found works best is cut a baggie that's about the size of your membrane, right, from this roll. Give it a little bit of space because you want things to shake around. So the filter paper is larger than our membrane. So if you make it just a little bit bigger than your filter paper, that's good. And then textured side down, and then you create a little pouch, right? And so actually I don't seal it just yet. Just get all these bags ready while we're doing a wash, and then it'll be much easier to add our membranes. So after our 3rd wash, now we're going to add our membranes to our baggies that we made. So just take your bag, and because we left one side open, you can just simply unfold it. Place your membranes into the baggie, right up against the edge. Just like that, right? And again, I think looks like I'm doing a solo. And then seal the edges, leaving the short edge open so we can add our solution, but sealing off the long edge. All right, and just, you basically push, you can see the little red LED, leave some space, because we can always trim the baggie. Go until the red LED, and I like to just wait a second, let the thing cool. Don't rip it too fast, because if you do, sometimes you'll leave a little hole and then your solution spills everywhere. And because I've been paranoid lately, I've been doing it 1 membrane per, but again, you could go back to back. And if you do, just make sure the membranes are protein side out. For each little baggie, we use 10 mils of antibody. In this case, I'm using a 1 in 2,000 dilution, so you can figure out how much antibody to add. So I got my antibodies prepared. We put it in 1% milk and TBST with our antibody. Pour in your antibody solution. This would be our primary antibody. For this example, we are using an anti-histag antibody. Squeeze out any large air bubbles. I try to make sure it's not super wet at the top because it won't seal quite as well. And then just seal the top off like we did before. Peel off nice and gently. And then hope it doesn't leak. Positive vibes, positive vibes. And then repeat for the second baggie. Again, antibody solution prepared. You can make it in a larger container if you like, and then just kind of roughly pour, or you can just do it in 2 separate ones, whatever your pleasure. And no leaks, no leaks. Incubation can be done in one of 2 ways. Let me change the camera angle here. You can do it at 1 hour at room temperature if you like, which is generally sufficient. Or if you don't quite have the time, and today I don't quite have the time, you can do an overnight incubation. But because we are working in milk powder, we'd like to do that on ice or a cold room if you have. But since we don't, I just get this big cooler of ice, put in this container just in case there are leaks, and then just let it incubate on ice overnight. I like to keep it protein side up, and I can tell because of where I notched it, top left corner. Close the lid, and then we will see these 2 tomorrow morning. Bye. So it's next morning. I wasn't quite ready to do the filming, so I just took it out, left it at room temp while I was getting ready. This is the antibody that we used. It's a goat anti-6 his, which means it's an antibody that binds to the 6x his tag, and it was produced in goat. And sometimes you'll see it as IgG because that's the type of antibody it is. So it'll be called a goat anti-6 his IgG, or a goat anti-6 his antibody, or our goat anti-6 his primary antibody. Anyway, so we're done now. Now we're simply gonna free our membranes from the bag, and then we're gonna do what we did last time after a block. We are going to wash it in TBST 3 times for 10 minutes. Like we did in our previous step, we're going to prepare our baggies while the membranes are washing, so we can add our secondary antibody, which we're going to dilute in 1% milk and TBST just like before. We will use a 1 in 1,000 dilution. In this case, I made a double batch, and I'm just going to split it because it's easier this way. The volume of secondary antibody is not quite as critical because we do tend to have a lot of it. The secondary antibody binds to our primary antibody, right? So remember, our primary antibody was a goat anti-6. This one is going to be a rabbit anti-goat IgG, which means that it's made in rabbit, and it's going to bind to goat antibodies. And remember, our primary antibody is a goat antibody. So our baggies, just like before, we're going to seal them. And then once they're sealed, we're going to add our antibody solution. And we're going to simply incubate 1 hour at room temperature. And for those of you paying attention, guess what comes next? That's right, 3 washes, 10 minutes in TBST. These are the last wash steps, I promise. So now our secondary antibody, which has our enzyme, horseradish peroxidase, conjugated to it, are bound to our primary antibodies. We are now going to detect it using these reagents that they simply call detection reagent 1, detection reagent 2, using detection system called chemiluminescence. Now you have to mix them in equal volumes, 1 to 1, and generally 1 mil per blot works. So I'm going to take 1 mil of detection reagent 1, 1 mil of reagent 2. That'll give me 2 mils total. And then that should be enough for both, but we in class will probably use just a little bit more because it takes a little bit of, you have to be careful when you add the reagents. So nice and slow, I'm going to add and just cover the membrane as best as I can. Sometimes you can just move the membrane around a little bit, making sure that the substrate covers the membrane as best you can. And then we just let the reaction proceed for 1 minute. Sometimes if I see like some spots that are not fully covered, I'll just gently use the pipette tip, use the surface tension to just kind of move the liquid around. Don't scrape the membrane. But otherwise, just try to let it sit undisturbed. After letting it sit for at least a minute, I remove the excess blotting reagent. So I do that by simply just tipping it onto a paper towel, letting the paper towel soak up the excess reagent. And then we are ready to visualize. We can either just wrap it up in saran wrap, or put it in a baggie, or just place it on top of the machine just like this. So this is what our blot looks like after chemiluminescent detection. It's not the prettiest blot, but it does kind of tell me what I want to see at the very least. At least I know what I'm looking for. Ideally, what we'd like to do is we should optimize the primary antibody concentrations, the secondary antibody concentrations. That'll help with things like the background that we're seeing here and some of the non-specific bands, but I don't have time for that. Also, generally when we look at blots, we'll just look at those black bands that you see and we don't see the membrane itself, but this gel dock does allow us to superimpose the membrane. So it's neat doing that because then you can see the lanes, the appropriate lanes, and then you can also see the ladder and that kind of thing. Sometimes without that, it's a little bit hard to orient where your signal is coming from. But I didn't take a picture of that, so kind of a moot point. But overall, blotting is a relatively simple process. Really the hard part about a Western blot is making sure that you have good protein samples, making sure that you transfer your gel properly. And then after that, it's just simple incubations and washings.